We spent quite a while talking about slope. Now we're going to put that together, put it into the equation of a line, and we're going to come up with a way that we can recognize lines and that we can work with lines, and there's quite a bit we can do with them. So this is the beginning of a few lessons that have to do with this particular format of an equation. So by this particular format, I mean this. Y equals mx plus b. You're going to hear a lot of that in the near future. Y equals mx plus b. We already know what y and x are. Those are the variables in the relation. Those are the two things that are being related to each other. We already know what m is. That's the slope. B, I'm going to identify in just a minute. All right? So let's fill in the blanks to get started. The equation of a line can be determined if you know the slope, as I just said, because then we can put it in for m. And I'm going to say the other thing that we need to know is the starting value. And more on that in a second. The form is y equals mx plus b, where m is the slope. I already talked about this. And b is the, in this case, I'm going to call it y-intercept. But y-intercept is just a graphing way of thinking about the starting value. Okay? So we're going to think about that as the starting place on the graph. All right, so these are the two things. If we know the slope and if we know the y-intercept, then we can come up with the equation of a line. So we talked about y-intercept in the lesson. Let's see. Let's go back and see if I can find it here. Just quickly. Remember, we talked about x and y-intercepts back in a lesson on the slope formula. And we're not going to be doing x and y-intercepts, but just to remind you what the y-intercept is, it was this thing here where a line crossed the y-axis. We're going to call that our starting value. We're going to call that our y-intercept. So that is what b is. From here on out, it's that y-intercept. Okay, back to our current lesson. State the slope and the y-intercept of the following. So here's something else that we need to become really familiar with. Think y equals mx plus b. In fact, it won't even be a bad idea just to write that out again. Y equals mx plus b, where m is the slope, b is the y-intercept, which I'll write as y-int for short. So if I want to identify them, then in this case, there's my slope, there's my y-intercept. M equals 5, b equals -1. Notice how it's -1. The reason why it's -1 is because this formula is y equals mx plus b. So the formula involves a plus sign. If you look at the first example, it's 5x minus 1. The only way that I could switch from a plus sign in the general formula to a minus, as in -1, is if I think of my b as being a value of -1. So that negative sign there is part of the y-intercept. It just tells me that when I were to graph, if I were to graph the line, and I won't graph the whole thing, but say I were to graph the line, someone said, well, now that you know what the y-intercept is, just mark it on a graph. Here we go again, just get my proper pen. Okay, so here's a quick little XY grid. Someone said, mark the y-intercept on the graph. Okay, no problem. Well, it's at -1. That would be somewhere down here, right? If I didn't include that minus sign, that would mean something different. That would mean it's up here. This would be +1, but that's not the case, so I'll erase that. So the -1, the minus sign really matters. In part 2, there's my slope, there's my y-intercept. m equals 2/5, b equals, again, negative 3. In number 3, there's my slope, there's my y-intercept. So my slope, this is the first example we've had a negative slope. Again, remember, a negative slope means we go downwards from left to right, so that's all that's telling me. And when I write a fraction, I like to put that minus sign up on the top. Rather than just shoving it out front, I'll always stick a minus sign on the top. So it means the same thing, but I encourage you to put that minus sign on the top as well. So m equals -1/4, and the slope is 1. Positive 1, I don't need to write the plus sign, though, to indicate that. Slope, well, where's the y-intercept? Well, y-intercept always comes here. So if there's nothing written, we can assume that the y-intercept is 0, right? I never write plus 0 down, but it's assumed to be 0 if it's not written down. And that would mean, just to go back to another quick sketch, that my y-intercept in this case is 0. So in this case, my line, which I haven't drawn the line in this case, but my line would go through the origin. That would be, when I did graph this number 4, that would be a case of direct variation. Number 1, the other one where I drew the grid, this one would not go through the origin when I graphed the line, and that would be a case of partial variation. So anytime the y-intercept is 0, that's a way to tell if something's direct variation. Write the equation in y equals mx plus b form for the following. So something with a slope of 3 and a y-intercept of 5. Okay, well, slope is m, y-intercept is b. We want to put everything in this form, so we just put them in the correct place. Y equals 3x plus 5. Done. Write the equation of a line with a slope of 2/3 and a y-intercept of -4. All right. Y equals 2/3 x minus 4. Remember that minus sign? When I add that in there, it just becomes a -4. Write the equation of a line that if the rise is -4 and the run is 5 and the y-intercept is 0, -2. Okay, so now we're getting a little bit trickier here. They give us the rise and the run. They don't tell us what the slope is, but they tell us what the rise and the run is. So we need to remember that slope, m, is equal to rise over run, and so it's just -4/5. That's what they're telling us. The slope is -4/5. And they're telling us the y-intercept is 0, -2. Well, remember that y-intercepts always have x values of 0, so by giving it to us as an ordered pair, they're not telling us anything we didn't already know. The x value is 0. The y value is my y-intercept. That's where it's going to cross the y-axis, so b is just the -2 part of that. So again, putting that together in y equals mx plus b form gives me y equals -4/5 x minus 2. Write the equation of the line in the given graphs. All right. Well, I can identify the slope and the y-intercept from a graph. Y-intercept's the easiest. Where does it cross the y-axis? B is equal to 4. The slope, what I want to do is, if I've got the graph, is I want to find a couple points where I can easily tell what the rise and the run are. I still need the rise and the run. So I could go from, say, here to here, right? Then I'd be going down by 1 and 2 to the right. Or I could go farther over. I could go over to here. Or I could go over to here, and I could pick any of these points and just find the rise and the run between them. It doesn't really matter which ones I do. I might as well stick with these two. The rise, remember, when we do the rise, we're going from left to right. This line is going downwards from left to right. So from the point that's farther left, we're going down by 1 unit to get to the point that's farther right. That makes my rise negative, -1. Again, that negative sign's really important. To go from the further left point to the farther right point, I'm going 2 units to the right. So this is my rise, this is my run, and then again I can put that together to get my slope. So I'll do that down below. M equals -1/2. And so putting it together, y equals -1/2 x plus 4. Okay, we're going to do the exact same thing for the next one to the right. Here's the y-intercept, 25. Now this one's got a scale that you have to watch out for. The x values, or n values in this case, are going up by 1 each time, but the y values, or c in this case, are going up by 25. Every block is worth 25. So I have to take that into account when I do my rise and run. And again, I can pick any 2 points I want. This time I'll pick some just farther apart just to show that it doesn't really matter. So if I go from, again, from left to right, going from 2 over to 8, I've got a run, delta x, of it's going up by 6. From 2 up to 8 is going up by 6. And going from the one that's farther left to the one that's farther right, my rise is going from 50 up to 125. So it's going up by 75 units. 50 up to 125 is going up by 75. So my slope is rise over run, 75 over 6, but that can be reduced. I can divide the top and the bottom by 3, and I get 25 over 2. And no matter what points I picked, it would always reduce to the same slope. So that's the good thing about slope, is it doesn't matter what points you pick as long as you remember to reduce. So my equation is y equals 25 over 2 x plus 25, or, and that's our general form, y equals mx plus b, but we are allowed to use other variables. In this case, the variables given were n and c to correspond with number of hours and cost. Remember that x is always on the horizontal axis and y is always on the vertical axis. So n is like an x value, and c is like a y value. So if I want to use the actual variables given in this equation, it would be c equals 25 over 2 n plus 25. And I could even change my slope to a decimal. It would be 12.5 if I wanted to do that. Sometimes it makes sense to do that. So then I could read this equation, and it would tell me that cost of whatever it is we're measuring is $12.50 per hour, n, plus 25 to start with. Our starting value is 25. This might represent, say, someone who's coming to your house to do a service for you, to clean your windows or mow your lawn or fix your dishwasher. I would interpret that to mean it costs $25 for the person to make the service call. Even if they don't do anything, then they charge $12.50 an hour for the work they do. The last one, total cost for an extra large pizza at the restaurant is $14.50 plus $1.25 for each topping. Write an equation for the total cost, C, in dollars, and the number of toppings, N. All right, so I haven't talked about independent and dependent variables in this lesson, so let me just remind you that independent variables are the ones that we choose, and then dependent variables we calculate based on what our independent variable is. If we're thinking about it graphically, then independent variables are always on the horizontal axis. And so normally, x is our independent variable and y is our dependent variable. In this case, though, we're using c and n. If you think about it for a second, the cost is going to depend upon how many toppings you have. So instead of putting x down here, I'm going to put an n down here because n is my independent variable. And instead of y, I'm going to have a c because the cost depends on the number of toppings. So it's going to be a graph something like that. The pizza costs $14.50 for no toppings. So again, this is just a sketch, just so we can see what's going on. It costs $14.50. So if I get no extra toppings, that's how much I still have to pay for my pizza. But then every topping I add is going to make the price go up by $1.25, right? Sorry, that should be number of toppings down there, not price. 1, 2, 3, 4, etc. And again, this is just a sketch, so it's not meant to be exact, but it'll just give you an idea. The graph will look something like this. It's going to go upwards. As I add more toppings, the cost is going to go up. So now that you can see it, then let's put this in terms of y-intercept and slope, because that's really what we need to know. The slope is how much it goes up for every topping we add. That's going to be the $1.25. It should have been a highlight there. Okay, there's $1.25. That's my slope. Every topping I add, 125, my rise is 125, $1.25 per topping, which is just 1.25. I don't need to leave it as a fraction in this case. My y-intercept is where I started. So even without adding any toppings, it's going to cost $14.50. So now we can write our equation. So y equals mx plus b, sure. But y is replaced with a c, so c equals 1.25n, which replaces x, plus 14.50. So here's an equation that you could use to calculate how much it would cost for a pizza from this pizzeria, depending on how many toppings you wanted to put on it.